on this rotation.
Yes. That's okay. But okay, I'll stick to a yes no. Okay.
Okay, so if rotation is based on orbit and the orbit hasn't been detected, which means we had to abandon Newton.
No, sorry. Rotation is not. It's not based on orbit. The sidereal rotation is based on uh, the Earth rotating around its axis.
So, so in a heliocentric model, you can have a rotation without an orbit.
Sure, you have stars which are rotating around their axis and nothing orbiting around them. Yeah.
No, not orbiting around them. The the luminaries orbiting around something, right? All the luminaries are in on a curved geodesic path according to relativity. So like nothing's really moving in a straight line. They're all moving along a curved path.
Uh, yes, but the rotation of the planet or whatever, or the star or the galaxy around itself is something different. It's got to do with angular momentum, something like that. It's not got to do the reason why the Earth is spinning around its axis is not gravity. It's not gravity. It's got to do with initial conditions. It's like a top spinning on your table. It's nothing to do with gravity. Of course, we need to have a model to understand why it started to rotate in the first place, but it's not linked to rotation. Whereas the revolution of the Earth around the Sun, that has to do with gravity, yes, and also with initial conditions, because you need to provide that initial velocity, yes. You still hear
Um,
me?
yeah, yeah, my bad, my bad. I was reading something. So yeah, I'm not saying that it's linked to gravity, but I'm saying like the motion of the orbit, like in a heliocentric model. Like this is the first time I'm hearing that these two aren't linked, right? I think that everyone believes or knows that the heliocentric model says with an orbit you need to have this rotation, like that the Earth's not saying that it's the Earth's rotation is dependent on gravity, but while it's orbiting, there is a rotation.
It's not necessary. It's not necessary. It's independent. The rotation around the axis is independent of the revolution around the sun. Totally independent. Yeah, except for tidal effects, such as so the Earth and Moon system. Apart from that, in first order, they're totally independent.
Okay, we know that they're independent motions, right?
Yeah,
Well, one works with the other. Like
you don't need
you
you
can't
don't
have the
need
Earth you can't have the Earth rotating but not orbiting. And you can't have it orbiting but not rotating.
No, you can have it orbited when not rotating. Yes, you can.
Bro,
And
how? Now I'm not saying a regular object. I'm talking about the Earth itself. And give me one scenario in the heliocentric framework that the Earth can be rotating and not orbiting.
but the other planets have different rotational velocities or angular velocity with respect to their axis. Uh, um, and I'm not even sure if one of the planets is even rotating in the other direction with respect to the angular velocity of the revolution. They're two independent things. The motion around the axis, the planet's axis, and the motion around the sun, they're independent. There can be subtle effects such as tidal forces or the effect of other planets or the fact that the system is complicated, is complex. There might be other influences, but in principle they're not related.
I'm not saying that they're related. What I'm saying is we're detecting this rotation via interferometry. Two different rotations there's supposed to be. One going
Yeah,
around the sun and one on its axis.
and the sidereal is precisely the difference between the two. The sidereal rotation is if you take say a cross, so you have two perpendicular arms, right, and symbolizing the interferometer, and then you make this cross rotate around the sun. There's two simple way you can circulate. You can move this across in a circular path around the center, and one is by keeping the two arms of the cross always parallel to themselves, meaning that they always point, say, north. I don't know, some other pointing towards some other very distant point, or you can move the cross with one of the arms always pointing towards the center toward the axis of rotation, the sun in this case. And so if our daily rotation, the one that we measure, the duration of the day, meaning from midday to midday, it's the one that's relative to the system in which the axes are pointing. One of the two is pointing toward the sun, let's say, and the other one is, and the sidereal instead is with respect to a system which coordinate system where the axes are, say, pointing towards a distant star. And so what you're saying that an interferometer, if it's orbiting, is also rotating, is the second case, where one of the two arms is always directed towards the sun. Then the angular velocity of the orbit is the same as the rotation of the interferometer around its axis. And this is the thing that could be detected, meaning that the interferometer rotates 360 degrees in 1 year. But then, if you have that interferometer is on Earth, you have the two rotations which are compounded. They have the composition of the two movements, and then what is detectable, which is the rotation with respect to, say, an inertial frame, would be the difference between the two angular velocities, which is precisely the sidereal rotation. So it's that. I'm not sure I can express myself without drawings and without being able to.
I totally get what you're saying, but we're specifically talking about the Earth right now. And
Yeah.
I haven't heard you provide any example of an Earth rotating, not orbiting the sun, and still being heliocentric.
Yeah, but I don't. We have to go back. What is the point of this?
I'm trying to get there, but every time I ask you like something simple, I gotta like redefine it a little bit just to get a little bit more clarity, and then we kind of get there. But I'm trying to bring all this together, and we're still gonna get lost in the weeds because you don't really agree on some of the other things that we observe. So it's just like, and you admit that you don't have the full capacity to speak on it intelligently, which I appreciate. You being honest about that. So it's a little bit difficult to get to highlight the issues here. But the point is that in a heliocentric framework, the Earth is orbiting the sun.
Yes.
We're also experiencing a sidereal rotation,
Yes.
but we're only detecting one of those motions,
Yes.
while the interferometer is designed to detect both. And
No.
we see, you say no, but it is true. Otherwise, they would not have designed it that way. They wouldn't design it. And let me not get off into the weeds, but they wouldn't have used this instrument if it didn't detect the motion of the Earth on an orbital path. Like
Sorry.
that's just,
Are you talking about Bickerson Morley?
yeah, specifically about Michelson Morley, but
No.
that's not the only person that has done interferometry tests.
Okay.
Um,
Okay.
they've done some, and I'll get to some of the other things to address some of the other points, but I just want to be clear about this. So I'm not saying that it's not possible to have something orbiting without rotating. I'm not saying that. But in a heliocentric framework, the globe Earth has to be orbiting and rotating. The interferometry is supposed to detect both of these motions. It only detects one. The way that they describe this is saying, hey, we got rid of the ether. Let's also change physics and we'll say objects move in a curved geodesic. However, when you're on the Earth's frame, you're actually falling perpetually in free space in a straight path. And interferometry back then in 1887 didn't detect linear motion. So this was a win for Einstein to say, hey, I can have two different types of motion and I can make the top minds in sciences believe that these two contradicting things can happen simultaneously. You could be moving in an ellipse from one frame. However, at the same time, you're on a curved path, you're actually going straight. So one of the things that I probably should have went through is, and I don't know if I did. I think I did. Maybe I did. It's been so fucking long trying to get through these questions, but I think I went through the laws of logic and what the implications to some of the laws of logic, like the laws of non-contradiction, which is that no two statements can be both true and false. Also, the law of what is it, middle ground, I believe, where you have to exclude the middle between truth and falsity, right? So it's you can't say that something is moving in a straight line and on a curved path. In relativity, you can, but that seems to violate the law of logic. And there's other different things that are in contradiction. Let me see if I can remember real quick.
Yeah. I disagree.
Okay, tell me what you disagree with.
I disagree with, for one thing, that the fact that, as I told you, as far as I know, Michelson Morley was not designed in order to detect rotational motion. It was designed in order to detect linear motion with respect to ether. It was designed to measure the difference in the speed of light in two different directions due to not to rotation but to linear motion, locally linear motion. And so it's an approximation of it's a linear approximation of the ellipse. So this was designed for. It didn't mean to detect a rotation. The second thing, which is what I was doubting my ability to give a 100% certain statement, is the ability of an interferometer in general to detect rotational motion. I now just thinking about it, I think that it can, as long as the rotation axis is not perpendicular to the axis of to the plane of the interferometer itself, because otherwise it cannot detect it, in my opinion. But still have to make sure of this. But this is my first impression. But yeah, it can detect rotation of the interferometer itself, meaning that the frame in which the interferometer is stationary is rotating with respect to an inertial frame. The inertial frame in the heliocentric model is the so-called fixed star frame, and in that frame, the interferometer would rotate with the sidereal rotation, because this is just geometry and kinematics. The net angular rotation with angular velocity with respect to an inertial frame would be the sidereal. So if ever an interferometer is detecting an angular velocity, this will be the sidereal, which is not, as far as I know, what Michelson Morley was set up to detect. And the fact that they did not, that the null result only was used by Einstein in 1905 to um, um, formulate the special theory of relativity. And the general relativity came as a second step in order to be able to extend this and to get rid of the classification of systems of frames between inertial and non-inertial. It would be a general theory, meaning covering all kind of frames, even the accelerated ones, and also gravity because of the equivalence principle.